Hello again, this is part 2 of the LabView intro. Here I'm going to show you how we are going to be using LabView and some hopefully helpful tips and tricks as we go. To start, come down here to the Start menu and scroll down to the ends. I recommend doing this instead of typing it in here, but if you scroll down to the ends for National Instruments, you'll see LabView. And you're going to be looking for something like this. This is spring 2022, and we're using the 2020 version of LabView. We don't update these videos every semester, so it's possible you might be watching this in fall 22 or spring 23. There may be a newer version here for you. Most likely you are going to be using that newest version of LabView that is installed. Don't go into here and like open up the Robotics modules or anything like that. There are a lot of other things that can kind of look like this, but they aren't going to be exactly what you need, and it'll, when you're just starting out, it'll send you down a path where you'll kind of be a little lost. You won't know. It'll look a lot like what you're trying to do, but it'll be a little bit different. Don't go down that path. Just open up the basic LabView of the most recent version. When you do that, this screen should pop up, and you have the option here to create a new project or open an existing project. A project is a little bit more involved than what we're doing. So instead, just come up here to File and click New VI. That keeps it simple for us. You can split your screens like this. So long as your program doesn't get to be too big, then you can see both your block diagram and your front panel at the same time. That's nice and convenient. A lot of the things I'm going to be showing are going to require a DAC to be plugged in or to be simulated. Here in this lab, I'm going to be plugging in the DAC that we use. We're going to be using this. We use several different DACs, but this will be a common one that we use. It's a USB 6001. It's a newer model, but it's a kind of more cost-effective, just basic data acquisition system. This is the hardware that we plug up to the computer that the software runs. You'll just plug it in via USB to your laptop. We have some terminals on this side. This is the analog side, so analog in-out. Over here, it's a lot of digital in-out. Then there's also a 5-volt power supply down here that we will use when we get to the accelerometer lab. Mostly, we're just going to be plugging into the analog channels over here, analog input channels. So I have one of those plugged in, and for me to show you what I'm about to do, you have to have that plugged in, or you have to have a DAC simulated. And I'm going to put up another video specifically for how to simulate a video. So if you are, say you're trying to prepare for the final and you're sitting in the engineering lab, one of the computer labs here on campus with an engineering image on it, trying to use the LabView there, you'll want to go and watch that video to see how to simulate a DAC so that you can do what I'm about to do. And that is, we want to, over here on our block diagram, we want to right click to bring up the functions palette. Now note, if we can have this permanently up, like if we go over here to view, we can have the functions palette permanently up. But that starts to take up a lot of our screen space if that's up here and we bring up our, like on this side, we bring up our controls palette. If we have all that stuff open, it can get to be kind of congested. So I prefer to keep those closed because you can just quickly right click and bring that up. Typically, the first thing we're going to want to do is come down here to Express and go to Input and get the DAC Assistant. There's more than one way that you can get to this, but that's a pretty direct route. So you left click then on that, you drag it over here and you place it. And it's going to do a little bit of initializing, then it will open up. And there is a lot there that we're going to need to do each time. The first thing is we want to acquire signals. typically, like I said, it's going to be an analog input, and we're looking for voltage. The only exception to this is when we do the thermocouples, we're still collecting a voltage, but it's a little bit more specific. And in that case, we'll be selecting temperature inputs. But most cases, voltage. That's what we'll do here. So here we see I have the USB 6001 plugged in, so that's what shows up. If you simulated 6001, it will show up here. If you simulated one when you were at home practicing, and then you come in and you plug one in here at lab, you'll see both, and you want to make sure you pick the right one. You should be able to figure that out based on the names that are given. But here we have 7 input channels, and typically we're just going to want to pick the first one. If you wanted to pick multiple, so this is getting into some of the tips, you can hold down shift and we can pick 4. Say we wanted to just pick 0. So some of the labeling they use might not be so intuitive, but AI0 is the A and the I are for analog input, and 0 is the first channel. So 0 through 3 are the first 4 channels. If we wanted all of them, we hold down shift and pick all of them. If we just wanted to select a few, then we can use control. Similar to how we do a lot of selection in computers. Once you pick what you want, hit finish, and then it takes us here to where we can configure the DAC Assistant. There are a lot of important things here. One, down here you can pick whether you want the n samples. So say you just run it where you take 1,000 samples and then it's done. Or if you want it to just run in a continuous loop, then you do continuous samples. And we're going to do examples of both of those throughout the semester. Up here you can set the range. Remember, from what we just covered in lecture, we can minimize the quantization error by limiting our range relative to what we're measuring. Right? We don't want it to be smaller or we'll get clipping, but if we keep it small relative to what we're measuring, then we'll minimize that quantization error. Typically, we're going to be using the differential here. That we have the first 4 channels of the 6001 are differential. So there you're measuring the difference between the plus and the minus. There's also this reference single-ended. We won't really be using that, but that's more if you have a kind of like a standard ground, like you're measuring the output of a battery or something like that, and you can use that. But mostly differential. That's what we'll be doing here. Down here, you can specify how many samples you want to read. So this is going to be the number of samples you read, and then rate in hertz. So this is going to be how many samples per second we take. That's what the hertz unit is. Big tip here is, say you're doing multiple channels or you just don't know which channel you picked. This is that channel. We picked AI0, so it's showing up here as a voltage. Say we don't remember that we picked AI0, or we're just confused what terminals, or where we want to plug in our wires on that terminal block. So we can click on the connection diagram and we can come in here and see the plus and the negative from the whole differential thing we talked about. That's going to be the second and the third terminals on that 6001 we're using. So once you pick everything you need, you can get back to the express task there. Once you get everything you need, you can hit OK. It'll do a little bit of thinking here to configure it. It says building the VI. So we'll wait for it to do that. Now, just to populate some things here so we can show you some other tricks, let's put in an add function. So I right-clicked to bring up the functions palette in the block diagram, hover over numeric, and I come over here to add. I put that on here. Could be a lot of things to demonstrate this. But now we have these things on here. You can see there are these nodes. If you hover over them, it's telling you X and Y. Here's X plus Y. So you can get to what all that is here. But if you wanted more detail and just to see what it is all at once, a useful thing is to come up here to Help and click Show Context Help. So this context help shows up. And here you can see what each of those nodes are. So X, Y, and X plus Y. That was the last thing we hovered over. If I come over here and hover over this instead, it switches to the DAC Assistant. Instead of having to come over here and hover over each of those to find out, say we're looking for the rate. We want to put in a control so we can control the rate. We can just look over here on the DAC, on the context help, see that's it, and then come to it directly. So that's a pretty helpful thing to have. And then also, there's this tools palette. Just by default, it should be out, but say that's missing. You can come over here to View. You can come down here and bring up your tools palette. And say if ever your front panel or your block diagram are missing, you can bring those up here. Like say I shut down the front panel. There we go. So let's do it that way. So Window, show the block diagram, and bring that back up. Now, as you saw in part 1, we wire up all the different components in our program. So if we want to take the data out and wire it over here to our add function, we can do that. There's a couple different ways we can do it. If you see right here, I hover over this and it changes to a wire spool icon. That is telling me that it's going to wire, and that it's doing that because I am set to this automatic selection tool. Say, you can pick if you want just one of the individual tools and you don't want it to guess which one you want, then you can pick that here. I usually leave it on the automatic selection because it does a good job of selecting what I want it to do. So I come over here, it says most likely wants to wire it up, so it does it. It's not perfect. There's some times where, say, you might have some control over here and you want to select it to turn it on or off, but it's thinking that you want to move it around or something like that. So this would be to move it around, this would be to operate it. So say if it is guessing or predicting that you want something other than what you actually want, you can just come up here and pick that individual one and click it. But usually this automatic tool selection works pretty nicely, works well, and is very convenient. Let's add in a few other things here. Say, this add function, we have our data that we're collecting through our DAC, and say that there was an offset error in it. If we want to adjust for that, we can come in here and create a control. So we can name this our offset. So anything then that we say that we don't have anything running into it, but it's telling us there's 10 millivolts. So if we wanted to subtract out those 10 millivolts, we can put -10 in here, and then it's going to have an add function. It's going to add those two together. It'll correct for that offset, and our output from that point on will be corrected for that offset. I'm just trying to populate some things on here. Let's put up another minus sign. Say we're or a minus function, and we want to split this to run into here, and then we changed our mind, we don't want this in here, so we select this and we delete it. Now here we're seeing in red X here, we have this wire to nowhere. There are some problems. If we ran this, the run button is up here. If you had looked a little bit prior to me doing that, you would have seen that it was a white arrow. We could have clicked on that and ran it, but now we have errors. To clean that up, if we want to clean up any kind of broken wires, we can hit Control B. So remember B for a broken wire. I just hit Control Z to bring that up. I wanted to show there's also this cleanup diagram there, so that will clean it up for you. That does a little bit more. If you just want to clean up the wires, that Control B is nice. I think that is about it for what we'll show here. Just kind of some of the tips and tricks for using context help, how to navigate through these windows and bring things up. I'll produce another video that shows you how to simulate that DAC when you want to do that, and then we'll get into creating one of the actual VIs that we'll use for lab.